Why can't I hear this guy? All right. Okay.
Hello. See, I'm soon Zwiga. Say, I'm soon Zwiga.
Thank you very much. Now I'm back. No. Am I audible now?
Yes, we can hear you now.
Well, excuse me. I didn't notice I was on mute. All right. Yeah. But basically, what I was talking about is what we have done. We have introduced representation of signed numbers. Representation number 1, which is the signed bit magnitude representation, with 0 representing the negative number and the ones representing the positive numbers. We moved on to the ones complement representation, where basically it involves inverting all the numbers in a given, all the bits in a given binary number. Example on the screen, we have a positive 3 and a negative 3. If you're given a positive 3, it doesn't change. The positive 3, you know, binary representation, it remains the same. But if you want to find a negative 3, you invert all the bits, then voila, you have your negative 3. So basically, this is the ones complement. We also have the third representation, which is the twos complement. All these complements, you see that for the same number, if you want to find the negative for the same binary number, if you want to find the negative of that number, there are 3 different representations with 3 different binary numbers. You need to identify the type of representation you are using. If you cannot identify the type of representation you are using, then it means it's confusion all over the place. You will not know which numbers you are using. So it's very important to identify, number 1, what type of representation are you using. So for the twos complement representation, twos complement, this is done by complementing, which is inverting all the bits, then adding a 1. The process, complement or invert, then add 1. Example, if we have 12, we're using example 12. Rafa raised a hand. Okay, Rafa, comment.
See, we can't see your screen.
Damn.
But I can see your screen, sir.
I can see your screen.
But we can see the screen.
We can see
Ah,
the screen.
Okay, yeah,
Ruafa.
now I can see.
Ruafa. Right, Shirede, comment.
I can't see your screen, sir.
All right, I think if others can see the screen, it means the issues are definitely on your side, because here I am definitely sharing my screen. Let me share it again. I'm definitely sharing my screen. So if you're not seeing my screen, it means you probably see it after the recording. We can see the screen. Thank you very much, Frederick. So if you can log out, then come back in, maybe you'll be able to see the screen. Right, two's complement. One, complement or invert all the numbers or the bits, then add a 1. Example, we've been using example of positive 12. Positive 12 is represented like this. 1 1 1 1 1 1 0 0. This is positive 12. If we want to find the negative 12 using the 2's complement representation, what you do first is to invert all the numbers. If we invert all the numbers here, we get 1 1 1 1 0 0 1 1. After you inverted all the numbers, you add 1. So to add a 1 here, what do we get? We get 1 plus 1, this is 0, carry 1. 1 plus 1, this is 0, carry 1. 1 here,
Hello, sir.
0, 1, 1, 1, 1. Okay. Comment, question.
Hello, sir.
Yes, I'm listening.
Iyo yamaisa 0 yo mama t positive 12 pepa mnombuti inenge ine 0 negative inenge iri negative 12.
It depends with the representation. If this is 1's representation, this is a negative 12. 1's representation. No, not 1's. The sign bit magnitude representation. Sign bit. All right, let me clarify there.
Thank you, sir.
This is sign. If I'm using sign bit representation, this is a negative 12 because the sign is the first number. But if I'm not using sign bit, normal binary number, that is a positive 12. That is a positive 12, normal binary number. But then if I ask you, represent that normal binary number using signed representation, find negative 12 using sign bit magnitude representation, then you use this. But in this case, we are not talking of sign bit magnitude representation. We are on 2's complement. How do you find the 2's complement of a given binary number? 1, complement or invert all the bits. We have complemented here. 2, add 1. We've added a 1 here. The solution we get, this is the 2's complement. This is the 2's complement of 12. So which means 1 1 1 1 0 1 0 0 base 2. This is negative 12 using 2's complements. Now watch side note. Where's something here? 12, normal binary number 12. It is 0 0 0 0 1 1 0 0 base 2. This is normal binary number. Negative 12 using 1's complement. Negative 12 using 1's complement. there. Atina. Nope, we didn't. Let us find it out. We want to find negative 12 using 1's complement. We just invert all the bits. So it is 1, 1, invert all the bits. 1, 1, 1, 1, 0, 0, 1, 1. This is negative 12 for 1's complements. Negative 12 for 2's complements, it is equals to this one and that one up. 1, 1, 1, 1, 0, 1, 0, 0. All those numbers, they represent 12. Negative 12, I mean, these two numbers. They represent negative 12, but they are not the same. What differentiates them is the type of representation you are using. So for the guy who was asking, is this not a negative 12? Yes, in another galaxies, it is a negative 12. When we talk of sign bit magnitude, this is a negative 12. But when we talk of a binary number, this is a 12. The same here. I'm sure this number represents something else. If we use other number systems, if we use another type of representation. But if we are using ones, it's a negative 12. And for this one, if you're using twos, it's also a negative 12. All right. So we have covered the ones complement and the twos complement. Now application. We said, why do we complement? Why do we use complements? Why do we assign bit magnitudes? It's basically to simplify subtractions. When we do subtraction, it is easier to do subtraction of two numbers when using complements. That is what computers do. Digital systems, that's what they do. They subtract using complements. What do humans do? Right, type of binary subtraction. What do humans do? Computers, we say they use complements. Humans, this is what you do. Example, we want to find the sum, the product. When we subtract, what do we do? The difference. Give me a term, I'm stuck. When we add, it's a sum. When we multiply, it's a product. What is it when we subtract? Someone help me.
The difference.
The difference. Thank you very much.
The difference.
Voila. The difference, we want to find the difference between 25, nope, 24 and 7 in binary. What is the difference between 24 and 7? All right. Binary representation. TPO 24. I gotta say, participate. Now you can unmute yourselves, participate. 24, I gotta say, in binary representation. Simplest way to find out 16, 8, 4, 2, 1. So it means 24 is 16 plus 8. So it's 1, 1, 0, 0, 0. Are we together? How did we find 1, 1, 0, 0? That is 24 in binary representation. I need someone to give me feedback.
Yes, we are together.
Yes, we are together. So, this is your chance to the number of the P. Because these are the basics. When you get into the X, Y, Z's, you are no longer required to think. When I say 24, you don't have to think. Can I calculate? Thank you very much. Can I calculate the number? Yeah, baby. Right. When I say 24 in binary, how do you represent 24 in binary? Binary numbers, they have 1 zeros, 1 zeros, 1 zeros. So basically, you use this. If you are using 3 bits, you only use this 4 to 1. This is 4 bits, this is 5 bits. So when you have 1, 1, 1, 1, 1 here, it means you are adding 16 plus 8 plus 4 plus 2 plus 1. When I have 1 0 0 1 0, it means I'm adding 16 pana 0. We don't add this plus 2 plus 1. No, we don't add this. So what this means, 1 1 1, it's 16 plus 8 24 plus 4 28 plus 2 30 plus 1 31. Is this correct? 3 7 15 31. So this is 31. What is 1 0 0 1 0? It's 16 plus 2. This is 18. 1 1 0 0 0. This is 16 plus 8. This is the 24 at Ruchak. Madam, no teacher. Do you get it?
Yeah, but
Thank you very much. So we have a 12 here. 24 minus, I said this is for humans. This is how you subtract 7. So for 7, we have 0 0 1 1 1 0 0 1 1 1. All right. So when humans subtract 0 minus 1, it can't. You borrow from the other number. So how do we borrow from the other number? If we borrow here from 0, we are left with a 1. And what do we borrow? We borrow a 1. What does this number become? It becomes a 1 0. It's not the normal, it can't borrow and you cancel for the normal subtraction. This is how we borrow in binary. I repeat. Let me go back. This is how we borrow in binary. 0 minus 1, it can't. I borrow from this number. Different colors. All right. I borrow from this number here. Okay. I borrow from this number. When I borrow from 0, I am left with 1. When I borrow from 0, I am left with 1. What do I borrow? I borrow a 1. And when I borrow that 1, what becomes of this number? It becomes a 1 0. A 1 0 in binary, it is a 2 in decimal. So you take this 1 0, you say it is a 2 in decimal. You say 2 minus 1. 2 minus 1, you get a 1. Right. Then you move to the next column. 1 minus 1, it's a 0. That's coming up. We have to borrow again. 0 minus 1, it can't. We have to borrow from this 1. When we borrow from a 1, we are left with a 0 and we borrow a 1. This 1 0 becomes a 2. 2 minus 1. Am I doing this correct? Nope. Just a minute. Let me come back. The process of borrowing, I think I got it wrong somewhere. I think I got it wrong way somewhere. Just a minute. If I can restart. That is why computers don't use this, because it's a bit complicated. 1 1 0 0 0 1 1 1 0 0. Subtract. All right. I started with the first column. Column number 1 2 3 4 5. Column number 1, 0 minus 1, it can't. We borrow. All right. The way I was borrowing, it's not the way you are supposed to borrow. When I borrow from the second column, I cannot borrow anything here because there is a 0. Okay. I cannot borrow anything here because there is a 0. But I can borrow from this one. Borrowing yacho, it can extend to the 4th column. So if I borrow from this one, I'm left with a 0 and I have a 1 here. This is the way, normal way of borrowing in binary as humans, right? You borrow from this one, right? My stilo, right? Then Archata Sikapana, we borrow a 1 from this 1 0. This 1 0 is a 2. If I borrow a 1 here, I am left with 1 1 and I have 1 1 that I've borrowed. Then I borrow again from these 2. I'm left with 1 1 and I have 1 1 that I've borrowed. This is the normal way of borrowing. Excuse me for the first one. It was wrong. This one is the correct one. So now you start doing a subtraction. 1 0 minus 1. I said this is a 2. This is a 2. This is a 2. So you say 2 minus 1. 2 minus 1, we get a 1. Here we have 1 minus 1, 0. 1 minus 1, 0. 0 minus 0, 0, 1, 1. This is the number we get. If you convert this number to decimal, this is 16 plus 1, this is 17. 24 minus 7 is equal to 17, correct. This is the way humans subtract. As you can see, even for me, it was a bit complicated. That's why computers have a way of subtracting. The way computers subtract is by using complements. We will use the same example to show how to subtract using my complements. If you want to get this practice, you need to practice. For those, I'm sure you are there, also this is what exactly happened there. Practice, redo the video, you get it. Right. We now move to the way computers subtract. Subtraction is a sensitive subject in computers. Addition, simple. Multiplication, simple. Subtraction is one other thing. Right. We will use the same example. We want to subtract 24 computers, or let's say digital. Digital systems. How do they subtract? This is how they subtract. We are using the same example, 24 minus 7. Right. This is how they subtract. We have steps. Subtraction by complements is done through addition. We have steps. Subtraction by complements is done through addition. As we can see, I've already mentioned addition, simple stuff. Subtraction is a bit complicated. So what do computers do? They do subtraction by addition because addition is simple stuff. Process. Number 1, take the first complement of the second operand. All right. Take first complement of the second operand. So in this case, the second operand is the 7. 2, add the binary numbers. Add binary numbers. 3, add carry to the result. This is the process we are going to use to add, to subtract 24, to subtract 7 from 24. All right. Step number 1, 24 minus 7. Step number 1, binary representation. 24 binary representation is 1 1 0 0 0. 7, this is 24. 7 is 0 0 1 1 1. 1 2 3 4 5. All right, this is 7. Step number 1, take the first complement of the second operand. The second operand is this one. The first complement of the second operand, we have 1 1 0 0 0. First complement, invert all the numbers. So this is our complement. Running out of time. All right, complement. Second step, add the binary numbers. After you found the first complement of the second operand, you then add these two. So instead of adding these two, instead of subtracting these two, 24 minus 7. What we do now is we add these two. I think it's sort of like this. 12 minus 7 is equals to 24 plus minus 7. Does that make sense? 24 plus minus 7. How do we present minus 7 one's complement? I think basically this is how computers do it. They add. So it's sort of 12 plus minus 7. We add the one's complement of minus 7 or 7. Right. Now to the addition. So we have 1 1 0 0 0. This is 24 plus the complement of 7, which is 1 1 0 0 0. If we add these two, we have 0 0 0. 1 plus 1, 0 carry 1. 1 plus 1 plus 1 plus 1. This is 1 1. Third step, add carry to the result. The carry is this one. We add it here. So we have a plus 1 on this side. 0 plus 1, 1. 0 0 0 1. This value is equals to 17. This is how computers subtract. They subtract by addition. Step number 1, subtraction using the first complement. Step number 1, take first complement of the second operand. We did it here. This is our second operand, and this is the complement. Step number 2, this is the first step. Step number 2, add the binary numbers. We've added the binary numbers. We have a carry here. Step number 3, add that carry to the result. Carry add by the 1. We've added to the result. We actually remove it and add it here. We get this number. This number is equal to 17. 24 minus 17, for us humans, it is 24 minus 7. It is 17. So which means the digital systems, they know what they do when they subtract using one's complement. For understanding, practice. Start with this example, do other examples. Practice makes perfect. All right, I think if I start the second one, I will probably not be able to finish it. So I'll have to stop here. And we know the procedure. I think one last session, it will be done for the day. Questions, comments?
Hello.
Yes.
Madi.
Congratulations, comrade. Who is that? Mateo. Right. Questions, comments so far? We have 5 minutes to answer questions. Nope. Benjamin Masoka, questions? Yes.
Yes, sir. Sorry, I don't know if I'm taking us back.
No
but I think
problem.
it's,
You can take us
yeah,
back.
I say on the subtraction of binary subtraction there. Please revisit that one.
Binary
For the
subtraction
borrowing.
for humans, for the borrowing.
Yeah,
Okay.
the borrowing part.
Okay, the borrowing part. We're subtracting 24 from 7. We said 24 is 1, 1, 0, 0, 0. We said 7 is 1, 1, 1, 0, 0. Let me put out like this: 1, 1, 0, 0, 0. We have 1, 1, 1, 0, 0. All right. We are subtracting. We said 0 minus 1, it can't. We have to borrow from the first column. This is the first column here. 0 minus 1, it can't. We have to borrow. If you want to borrow from 0 here, we cannot. There is nothing. We cannot borrow. We move on to the next column. We cannot borrow from that 0 again, but we can borrow from this 1. How do we borrow from that 1? Right. If, excuse me, if we remove this 1, we are left with a 0. Just a minute. If we borrow from this 1, we are left with a 0. Then the 1 we borrowed, it moves to that column. Now, we go back to the first one. 0 minus 1, it can't. We need to borrow. We can't borrow here, but we can borrow here. When we borrow from that 1, 0, this is what we borrow. What is left is a 1. What is left is a 1. Right. 0 minus 1 from this column, it can't. We need to borrow. So we borrow from this. When we borrow from this, we borrow a 1. What is left when we borrow from a 1, 0? It is a 1. Now we can start our subtraction. 1 minus 1, 1, 0 minus 1. I said 1, 0, it is 2 in decimal. So you treat it as 2 minus 1. 2 minus 1, this is 1. To the second column, 1 minus 1, 0, 1 minus 1, 0, 0 minus 0, 0, 1 minus 0, 1. And this number is a 17. With practice, you know how do you borrow. Any other questions? Any other questions? Let me see. Any other questions? Right. Before Chiminya asks his question, look here. 1 plus 1 is equals to 1, 0. Which means 1, 0 minus 1 is equals to 1. 1, 0 minus 1 is equals to 1. 1 plus 1 is equals to 1, 0. Which means 1, 0 minus 1 is equals to 1. Take note of that point for simple explanation of what we are doing here. All right, Ryan, question.
For subtraction, can we use a 2's complement?
Yes, we can, and that is why we have another session after this one.
Okay, thank you.
Okay, and I think that's it. You know the procedure. I'm going to end the meeting when we continue, we start with, we finish up the ones complement, subtraction using the ones complement, then we move to subtraction using the second complement. When you join the meeting again, mute yourselves. Otherwise, you risk being removed from the session. On to the next one.